In this recording sizobe discuss the different types of events in probability. In the description box there are other lessons ongawabukela are related to probability lana ka grade 10. Now asikhulume ngade different types. So the different types. The first one is this one, mutually exclusive events. An example might look like something efana nalena. In other words, we have what we call an intersection kuma mutually exclusive events. A mutually exclusive event uyibona ngani? Intersection. Uyibona intersection. The second type, it's mutually exclusive. A mutually exclusive event, it's something efana nale. Mutually exclusive events, X, no Y, two events. Lama events lawa, no intersection. There are no intersection. So these types of events are useful, especially nangabe uzobe usebenzisa the probability laws, the two laws. The third one, exhaustive. An exhaustive event, it's the same sketch as this one and this one. Why do I say that? An exhaustive event, it's an event where all the elements were taller within the sample space. This is the sample space, the rectangles, A, B, C, D, E, F, G, H. Ne? So all of the outcomes or the elements angaphakathi kwale sample space, it's either, or let me say, they are shared between u X no Y. Ne? There's nothing outside lama events. Everything, it's either ku X or kubani ku Y. Nangapha, even this one, the first one, this mutually exclusive diagram, this is also an example of an exhaustive. Ngoba everything, it's either ingapha ku A or ingapha ku M or ngapha ku N. It's either ingapha ku M or ingapha ku N. So an exhaustive, it's what? It's wherever our outcomes are either ku X or ku Y, either event 1 or event number 2. Event number 2. Then it's sibe nama complementary events. A complementary event is a combination of a mutually exclusive and the exhaustive. Ne? And the exhaustive. So check this out. So for an exhaustive event, CT, okay, in terms of the probability laws, I think you explain it in terms of the probability law. So these are the laws. I hope usawakumbula. Number 1 and number 2. So in terms of the probability laws, mutually exclusive events. Number 1, okay, I think it for mutually exclusive, inclusive, mutually inclusive. In terms of the probability laws, we say since it's in an intersection, the probability of A and B, this is greater than 0. The probability of A and B is greater than 0. This is number 1. Number 2, for mutually exclusive. For mutually exclusive events, CT, the probability of A and B, the intersection, is equal to 0. There's no intersection for mutually exclusive events. Yes? Yes. Number 3, exhaustive events. It means that the probability, okay, since lana sino X no Y, okay, well, let me use the same alphabets as Lapa. So you shouldn't be confused. The probability of M and N, the intersection is greater than 0. Ngoba not dealer. It means that the intersection is greater than 0. Mutually exclusive X and Y, the intersection is equal to 0. And then the number 3, so the probability of X and Y, of the probability of X now uhlanganisa ne probability ka Y, you should get ubani 1. For number 4, it's basically exhaustive and mutually exclusive. So these conditions weigh 2. For number 4, it means that the probability of x and y, it should be equal to 0, and the probability of x plus the probability of y, it should be equal to 0. So this is mutually, complementary. This is complementary. This is complementary. This is complementary. So lana besne exhaustive la. Exhaustive. So these equations are important, especially nangabe bagupha ama-probability problems where they say events are mutually exclusive, mutually inclusive, then you know what to do. So for example, let's start maybe 2 examples. Maybe 2 examples. So example number 1. So we are given that probability of A is 0.4. So the probability of A, this thing. So the probability of A, alright, yes, no. The probability of A is 0.4. The probability of A or B it's 0.5. So langshi ama-tick corner, I'm showing you these are given values. So I'm given 2, this one and this one, and then but it determine probability B if A and B are mutually exclusive. So mutually exclusive events, the probability of A and B are equal to 0. So it means that I'm given A nangomunye probability A, and then lana it's going to be 0 ngoba the number one, let's do number 1. So inside this equation, the first one, so sizoti the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. This value is 0.5. Probability A is 0.4 plus is for the probability of B. So the probability of B is unknown minus the probability of A and B, it's equal to 0 ngoba the events are mutually exclusive. Then we solve for B. About 0.5 minus 0.4 siyamtranspose so that ikusale lo B kuphela. So 0, the probability of B minus 0 is probability B. 0 is 0. There's no need to transpose. 0 represent nothing or represent nothing, so there's nothing lapha. So answer it is 0.1. So the probability of B is equal to 0.1. Number 2, if the probability of A and B is equal to 0.3, so this time as na 0 says no 0.3, we substitute again 0.5 0.4 plus the probability of B minus 0.3. Then we solve for B about 0.5. Remember lagu number 2, but the probability of A and B is equal to 0.3. This doesn't change. The only thing I change here is the probability of A and B minus 0.4 plus 0.3. The probability of B, answer is 0.5 minus 0.4 plus 0.3. Our answer is 0.4. So it's 0.4 equal to the probability of B. Let's do one last example. Example number 2. So lana we have 2 events, C and D are mutually exclusive. So now that mutually exclusive, we know that the probability of C and D must be equal to 0. Yes, ngoba They are mutually exclusive. There's no intersection la. With probability of not C, so bangiphe this one, not A not C is equal to 0.3, and the probability of C or D, bangipha this one, determine D. So therefore so sebenzisa which one now? Not C. Right, lama equation ayachinja la kuyoba u-C kube u-D kube u-C kube u-D. So ngoba basebenzisa ama-alphabets are different, not we have to change la C D. Uyabona, I have to calculate bani u-D, so I need to calculate this one. Uyabona, I'm given not C, this one and this one, they are mutually exclusive. Lana it's 0. Since this one kasi yang nayo, I cannot calculate to D la. So the first thing esoyenza sizo calculate this one. So sebenzisa number 2 to calculate to probability D. So the probability of, okay, so lana the probability of not C is equal to 1 minus the probability of C. So qala ngo calculate to probability C qala before so calculate the probability of D. So not C 0.3, 1 minus the probability of C transpose about probability C, 1 minus 0.3, answer it's 0.7. Then we can use the equation number 1. So this was equation number 2, equation number 1. C or D is equal to probability C plus probability D minus the probability of C and D. So it's minus 0, probability C is 0.7 plus the probability D equal to C or D is 0.8. The probability of D, I think this thing. So you have about 0.8, let out 0.7 to the left, you have about probability D. So our answer is about 0.1. This is the probability of D. So it's just a matter of knowing how to manipulate the equation to whatever variable uzobe ufuna simplify. So this is our last example and the end to our lesson. I hope we enjoy it. I hope we pull some value out of this discussion. Check out the description box for more content related to a probability grade 10. So yeah, I'll spawn on the next lesson. Bye bye guys, peace.